Alright guys, in this video we're going to do everything for quadratics. I am going to have something that I have you turn in, but it's going to be at the end. This is for pre-cal. It's going to be at the end of the video, so make sure you go all the way through. So we have two different forms that we'll find quadratics in. Vertex form is f of x equals a. We're not really going to deal with a b, but you could have a b value here. X plus. Will we deal with a b? No, we will not. C squared plus d. Okay, and so we looked at this before. Our vertex comes from here and here. So remember, this is your left-right movement. This is your up-down movement. And that's where the vertex is going to come from. That's why this is called vertex form. So your vertex is going to be at negative c comma d. Because remember, if it tells me x plus 2, I'm actually moving to the left 2. So that's why this is negative 2 at the vertex. So that's vertex form, and then we have standard form. And that's when what we use for the quadratic formula. So we're going to use both of these. So the first thing that I want to talk about on quadratics is if a is positive and if a is negative. Now on a quadratic without restrictions, your domain is going to be all real numbers, no matter what, unless they give me some sort of restriction. But your range is not. So your range on a quadratic where a is positive, the range is going to go from the vertex up. So your range is going to be I wrote vertex before and people kept putting that as their answer, so I'm not going to put it on this one. What I'm going to put is it's going to, for this one, it's going to start there. It's going to be f of negative b over 2a, which you have to figure out what this number is to infinity. And on this one, it's going to be facing down. So your range is going to be from negative infinity to f of negative b over 2a. And you have to figure out what that is again. So that's the first thing, the domain and range. On this one, your domain is a minimum value because it's the lowest point. On this one, your domain, or sorry, I don't know why I said that. Your vertex is a minimum value because it's the lowest point, the vertex. And on this one, the vertex is a maximum value because it's the highest point. So if your a is positive, you're going to have a minimum, and it's going to come from the vertex. It's going to be the y value at the vertex, which is this. If a is negative, it's going to have a maximum, and it's going to be the y value at the vertex, which again is this. So that's what we're looking at. Zeros on either one of these, they're fairly easy to find. The zeros are, for this one we would use the quadratic formula, and for this one we would just set it equal and solve. So I'm going to do a couple of examples, and I'm also going to have you find the y-intercept. So if it tells me in the vertex form, okay, so it tells me this, and it wants me to find domain, range, zeros, if it's a maximum or minimum, what the y-intercept is, what the y-intercept is. I'm going to find all of that stuff. So I'm going to do the domain. I see that a is positive. Domain is all real numbers. The range, because a is positive, it's going to go from the vertex up. My vertex is at 2, 8. So that means that it's going to go from 8 to infinity. My zeros are going to come from setting this function equal to 0. Oh, I should have given myself one where it didn't give me negative value. That was dumb. So I'm going to make this minus 8. Just because that was a bad example. So I'm going to add 8. I'm going to divide by 4. I'm going to square root. Because I did this square root, it's both plus and minus, and I'm going to add 2. So these are my zeros, meaning that there's two different zeros. There's a 0 at 2 plus the square root of 2, and there's a 0 at 2 minus the square root of 2. And my zeros, y equals 0, so that's why I put that. The y-intercept is when x equals 0, so I'm going to plug that in. So the y-intercept is 8, which is going to be 0, 8. Did I do it everything? I didn't state if it was a maximum or minimum. This one is a minimum because a is positive. Now I'm going to do it with the other format. Okay, so I don't think this one has zeros. Hang on. 3, 4. Let's make this 4. Okay, so the first thing I'm going to do is the domain and range. This is a positive a. My domain is always all real numbers. The range, because that's a positive a, is going to be the y value of the vertex, which is f of negative b over 2a. So negative 6 over 2 times 2 is negative 6 over 4, or negative 3 over 2. So now I have to plug that in. 2 times negative 3 over 2 squared plus 6 times negative 3 over 2 plus 4. That's 9 over 4 times 2 is 9 over 2 minus 18 over 2 plus, I'm going to turn that into a fraction over 2, 8 over 2. So that's negative 9 over 2 plus that's negative 1 over 2. So the y value is negative 1 over 2 at the vertex, and it goes up to infinity. Because this is positive, it's going to be a minimum value. The zeros, I'm going to use the quadratic formula, which is negative b plus or minus square root b squared minus 4ac over 2a. So negative 6 plus or minus square root 6 squared minus 4 times 2 times 4 over 2 times 2, negative 6, 36, 16, 32 is 4, 6 plus or minus 2 over 4, that's 8, so that's 2, and that's 4, so that's 1. So I have zeros at 2 and 1, so it's 2, 0, and 1, 0. Those are my zeros. Y-intercept is just this, so it's 0, 4. So the problem that I want you to do is I want you to do this problem and give me all of those pieces. Domain, range, if it's a maximum or minimum, find the zeros, find the y-intercept.